So you're starting with a blank piece of paper. You probably didn't copy anything down from the last video. That's okay. I just wanted to remind you that what we were talking about the other day is that we wanted to find the derivative at some particular value of c, and we said that that was the limit as x approaches c of f of x minus f of c divided by x minus c. And this limit is going to give us the slope of the tangent line at c. And just to make sure we're good with that, we have this function, okay, f of x, and we put this point P right there, let's say, and that point P is directly above the x coordinate, or the x value of point C. So we have the point P has coordinates c comma f of c. Alright, well, we're not really interested in that so much as we are this tangent line right there. In fact, we're interested in the slope of the tangent line, and that was defined to be f prime at c. Okay, so the slope of the tangent line is dependent upon where c is. And then the last video that you saw with me kind of experimenting with the new software is that f prime at x is equal to, now look at how this is different. F prime at c, this represents the slope at a particular value of x. Well, we can do the same thing. We can generalize f prime of x. In other words, we can express the derivative of the function f of x in terms of a function. So, so the limit as now h goes to 0 of this f of x plus h minus f of x all over h. And you've seen this before also. It's also a difference quotient. You've used that before, you've worked with that before, and now this allows us to, once we find the derivative, we can just go ahead and plug in certain values of x. So let's go ahead and do that, and let's use the same functions that we were talking about the other day. Keep trying to use that red, but let's try to use this same concept with f of x equaling x squared. Okay, so we know that f prime of x is, again, the limit as h approaches 0 of f of x plus h minus f of x. So you should be copying this down over h. Well, we know that f of x plus h is x plus h squared, because f of x is x squared. So if the input is the x, we're going to take the input and square it. So here, the input is x plus h. We're going to take the input and we're going to square it. Okay? And then minus f of x, well, we know what f of x is. F of x is defined to be x squared. Okay? And that's all over h. Well, we can still write this. We'll still write the limit as h goes to 0. And we're just going to simplify the numerator. We get x squared plus 2xh plus h squared minus x squared all over h. Okay, and so we're going to cancel. We can see the x squared minus x squared, and at the same time I'm going to go ahead and do a couple steps in one here. We're going to factor out what's remaining, and what's remaining here is the 2xh and the h squared. And just like what I had told you back in September, if you cannot cancel all the terms that don't have an h in them, then you've made a mistake. And if you can't, therefore, if you can't factor out an h in the remaining numerator terms, then there again has been some mistake made along the way. And so we can see we can factor out an h from the two terms in the numerator, and we get 2x plus h and all over h. And again, we know that if we were to plug in 0 into both the x's up in the numerator, the first part of the problem up here, then we would get 0, and we'd get 0 downstairs as well. And so we have to do something, and that's what this is all about. So we're going to cancel the h's, and we end up getting limit as h goes to 0 of 2x plus h. Now we can replace h with 0, and we get 2x. Okay, and so this is kind of interesting here, what we did the other day, and now what we're doing here with finding f prime at actually just x. And so let's summarize what we did the other day. We found the other day that f prime, let's put first x squared. So we found that f prime at 1 was equal to 2. We also found that f prime at 2 was equal to 4. So this was on Tuesday, Wednesday, whichever class you're in. Okay, so that's Tuesday, Wednesday. But today we found that f prime of x is equal to 2x, and so we can actually figure out that f prime is 2x, and now we can substitute in values of x like we did the other day. So f prime at 1 is then 2 times 1. Well, that's 2. So f prime at 2 is 2 times 2, and that's 4. And so we don't have to go back and do that same, use the definition of the derivative at a point. We can find the derivative. Just kind of come in for a landing here. We can find the derivative first and then plug in the points, the specific values of x, which enable us to find other values. F prime at -1. Well, that's 2 times -1. So we can find f prime at any value. We can find the slope of the tangent line at any value of x. You can see the slope of the tangent line depends on x. And so that begs the question, well, can we graph that as well? Well, of course we can graph that. We can see that f prime of x is a function that we can graph, just like f of x is also a function we can graph. So the whole idea here is the new lesson is letting you know that we don't always have to use this formula here, the limit as x approaches c of f of x minus f of c over x minus c. We don't always have to use that. We can, and plug in c, this will give us f prime at c, but also now the new stuff is that we can find f prime of x first, then plug in the value of x that we're looking for, so f prime at c would be 2 times c. And so that's what we could also do if we really wanted to. We can go, oh, well, f prime at c is just 2 times c, in the case that f of x is x squared. I hope that makes sense. I'm going to give you a couple problems to do on the back of this, and then I don't think I'll have time today to actually finish these videos, but Wednesday I should be able to finish the videos, and then I'll be able to give you solutions to the problems I'm going to give you in the back. Thank you.